Look up at the night sky. Those tiny lights, they are not just stars, they are gateway to the universe. From exploding stars to black holes that eat light, today you will explore astronomy like never before. So fasten your seatbelt because this is Introduction to Astronomy. Before we dive in, here's what you are going to learn in the next few minutes. First is what is astronomy? Second, branches of astronomy. Third is types of astronomical objects and its classification by scale. Fourth is stellar life and exotic objects. Fifth is galaxies and cosmic structure. Sixth, day, night and seasons explained. Seventh is space distance and timekeeping. Astronomy is the science that studies everything in the sky. It includes stars, planets, moons, galaxies, and the entire universe. Astronomers observe the sky to understand how the universe works. Astronomy is also one of the oldest sciences in human history. It helps us understand our place in the entire universe. Key branches of astronomy. First is observational astronomy, collecting data using telescope and detectors. It includes optical, radio, infrared, and X-ray astronomy. Second is theoretical astronomy, creating mathematical models and simulation to understand the universe, predicting cosmic phenomena and testing the theories. Third is planetary science. It is the study of planets, moons, asteroids, and comets. It includes geology, atmosphere, and formation processes. Fourth is astrophysics, the application of physics to astronomical objects. It studies stellar of physics evolution, black hole, nuclear fusion, etc. Fifth is cosmology, a study of the universe as a whole, focuses on origin, evolution, and ultimate fate of the cosmos. Now comes a very important terminology, that is astronomical objects. Astronomical objects are natural physical entities, associations, or structures that exist in the observable universe. They range from tiny particle to enormous cosmic structure. They can be classified by scale. First is planetary system objects. In planetary system objects, we will see stars, planet, dwarf planet, moons, and even small bodies. So let's see one by one. First is star, self-luminous sphere of plasma that held together by gravity. Example, our sun. Second is planets. These are large bodies orbiting stars cleared their orbital path. For example, like rocky planets, Mercury, Venus, Earth, Mars. Gas giants like Jupiter, Saturn. Ice giants like Uranus, Neptune. Third is dwarf planets. Planet-like bodies not cleared their orbit. Example, Pluto, Eris. Now comes stellar objects and system. These can be classified as binary or multiple star systems. These are two or more star orbiting common center. Second is variable stars. Stars whose brightness changes over time. Star clusters. These can be open clusters or globular cluster. Open cluster is young, loosely bound stars. Globular clusters are old, densely packed spherical clusters. Third comes is the stellar remnants. These are the end states of a star. These can be classified as white dwarfs. These are Earth-sized remnants of low-mass stars. Second is neutron stars. These are incredibly dense, city-sized remnants. Black holes, regions where gravity is so strong that nothing escapes. Fourth comes is the nebula, cosmic clouds. These can be classified as emission nebula. They glow from ionized gases. Reflection nebulas. These are dust reflecting starlight. Third is planetary nebula, shells ejected by dying stars. Fourth is dark nebula. These are dense cloud blocking light. Supernova remnants. These are expanding debris from exploded stars. Fifth come is the galaxies. These can be classified as spiral galaxies, These are shaped with spiral arms, example Milky Way galaxy or Andromeda galaxy. Second is elliptical galaxies. These are round, oval, older stars. Third is irregular galaxies. These don't have any definite shape. Now comes large scale structures like galaxy groups, small collections like few to 50 galaxies, galaxy clusters, 100 to 1000 of galaxies, superclusters, clusters of galaxy clusters, filament and void, largest known structure in the universe, cosmic web, network of filaments connecting matter. Now comes transient and energetic phenomena. These can be classified as: first is supernova, explosive death of massive stars. Second is gamma ray, most energetic electromagnetic events. Meteor and meteor showers, these are shooting stars. Exotic and theoretical objects. First, brown dwarfs. These are failed stars too small for sustained fusion. Second, exoplanets. These are planets orbiting the other stars. Magnetars, neutron stars with extremely strong magnetic field. Microquasars, smaller versions of quasars in our galaxy. Wormholes, these are theoretical. You can say these are shortcut to travel to space-time. Dark matter, invisible matter surrounding galaxies. For observation, there are some of the observational properties that we are going to see. First is luminosity, that is total energy emitted by the object. Temperature determines color and spectral types. Distance measured via parallax, standard candles and redshift. Motion, proper motion, radial velocity, orbits. Spectrum reveals composition, temperature and velocity. Now we are going to discuss motion of the sky. Why star moves? The stars appear to move across the sky because Earth rotates on its axis. Earth rotates from west to east, so stars appear to rise in the east and set in the west. The motion is apparent, not real. Stars themselves are not moving that fast, our planet is. The entire sky seems to rotate around a fixed point called the celestial pole, close to the north star Polaris. Day, night and seasons. Day and night is caused by Earth rotation on its axis once every 24 hours. The side facing the sun experiences the day and the side facing away experiences the night. Rotation direction is west to east. Seasons. Earth revolution around sun. The tilt of Earth axis is around 23.5 degrees. The sun's rays strike different parts of the Earth at different angles. The length of the day and night changes throughout the year because of the tilt. Now discuss some of the terminologies of timekeeping. First is solar day, the time Earth takes from the sun to appear in the same position in the sky, example noon to noon. Length is 24 hours, used for civil time. Sidereal day, time Earth takes to complete one rotation relative to distant stars. Length is around 23 hours, 56 minutes and 4 seconds. It is shorter than the solar day because Earth also moves along its orbit around the sun. Remember, every star you see is a sun. Every galaxy holds billions of stars, and the universe, it holds billions of galaxies. We are just made of stardust, and today you just took your first step into the universe. Please like, share and subscribe. Thank you.